now मुझे सोलह ही रहेगा उसको थोड़ा देखना वो सीन लेने के लिए इधर वहाँ पे जाकर बैठते हैं सीन कलेक्टर से लेके जाए ठीक है वो जाने के बाद मतलब उसको बोल देना कि सीन कलेक्टर है हाँ जाते हैं हाँ बोलो हाँ बोलो हाँ 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 चला रहा हूँ हाँ तो फिर मुझे देख लेना ठीक है तो फिर मुझे देख लेना हाँ हाँ वही Okay. Good morning. I can see that there are no participants as of now. So I will be waiting for next for more 5 more minutes, and then we will start today's live session. Hoping that those who will be viewing this uh, session on YouTube in the video that will be recorded and shared there, it might be useful for them. So for the live audience, we will still wait for next 5 minutes. देखना पड़ेगा थोड़ा जाके Hmm. Okay. So we'll be starting our live session now. It's 11:05 already. Before we start, I would like to introduce myself. I am the TA allotted to this course, the NEPTEL course on Integrated Waste Management for a Smart City. As per my personal information and brief, I am currently pursuing PhD under Professor Brajesh Kumar Dubey and Professor Makaran Madhav Bhongrekar from IIT Kharagpur in the specialization of Environmental Engineering and Management. So, in today's live session, like every other that we have had and will be having, we will be discussing total of 15 questions, among which I think one or two few are there which are numerical and rest of which is basic theoretical questions. So moving on with the session, how we will be doing is that since we have 2 hours allocated for this session and only 15 questions are there with us, I will be typing the question and then we will wait for a couple of minutes to think about the possible answers. So the first question, it is about which model is used for estimating the landfill leachate generation. So model for landfill leachate generation. And your options will be yeah. So among these four, which one can be the correct answer? You can also unmute yourself or use the chat box, whichever suits you for sharing the answer. The model which is used for estimating the landfill leachate generation. Okay, so the correct answer for this particular question is option two. That is the hydrologic evaluation of landfill performance. It is also often abbreviated as HELP model. HELP. Now moving on to the next question. Which of the following is the most So, which of the following is the most important property of geonet that helps in collection of leachate during waste degradation in landfills? And your option are okay. You can have about 2-3 minutes. We will have to wait for any question, and then the answer will be shared. Okay, so gravity drainage, yes, like gravity drainage occurs normally with the leachate. And in this particular question, since once the leachate reaches the bottom of the landfill, that is the liner, which also has geonet as one of its component. So once it reaches there and the geonet starts playing the role, then what happens is that the leachate that is seeping into the geonet, instead of percolating downwards,
what happens is that it rather spreads in horizontal direction and lateral direction. So that is why option 2 will be the correct option here. That is one of the roles of GeoNet, how it is designed, and that can also be used for detecting any kind of leak that is present there in landfill liner, in the landfill liner. So that is why the transmissivity in horizontal direction, this is the right option if the question is more specific on GeoNet, on the role of GeoNet. On the other hand, if the question is only related to landfill leachate, then the gravity drainage is one of the factors how the leachate comes to the bottom. While permeability can be the one due to which it may pass through, seep through the liner, then these leachate collection layers and other geomembranes, and might reach the ground level if there is some problem with it. So moving on to the next question. So it is the related to the slope of the liner. So what is the typical range of preferred slope of landfill liner for leachate collection? So for what should be the preferable slope? And your options will be, all of them are in percentages: 0.5 to 1, 20 to 35, 10 to 15, and 2 to 8. Yes, option 4 is the correct answer for this particular question. Now we will move on to the next one quickly. So the BOD is stabilized in which phase of landfill stabilization stage? Okay, so we know that the landfill has got various phases or stages during its life. So in which, among which of those phases is the BOD stabilized? And your options will be methane forming phase or stage, acid forming. Okay, so these are the options. When does the BOD get stabilized in landfill during during the four of its phases? I believe that questions like these, which are quite conceptual and in fact easy to deduce, these can be a part of the examination during the final stage of this course. Option D, final aerobic. So we will see that with the help of a diagram. Yes, at final aerobic, yes, the COD does get stabilized, but it is, if you look at this particular diagram, you can see that the BOD is at its peak during the acid forming stage, and it somewhere starts to get stabilized somewhere in the methane forming stage. So yes, final aerobic stage, definitely it is stable in this that particular phase, but where it starts, it all starts somewhere in the methane forming phase, because the COD which is present there in the leachate, it is all getting transformed to methane and other volatiles. So methane and other gases, mostly methane and carbon dioxide. So that leads to the reduction of overall BOD of the leachate and getting it stabilized. So now we will move on to the next question. I hope this was clear. So in this particular question, the answer will be methane forming phase. Now, next is kind of a match of the following type of question. I will quickly. So what you have to do is that you have to relate the landfill age with the landfill Well, this type it is written here. Sorry, with the leachate type. Leachate type in landfill. And I will draw that table quickly here. All the age, they are all in years. Okay, so these are your options. When will the landfill leachate behave like a biodegradable in nature or intermediate somewhere and then stabilized? In which of these ages? And in the meanwhile, I will also write the options below. Okay. Oh, you can think about this question, and I will be sharing the answer brief shortly. Hmm. It is. My live session is also 38. Okay. Okay, fine. So I will share the options. Okay, so among these, which one do you think is the correct answer? One C. So one you are saying it should be C, okay. One biodegradable in nature, so it less than 5 years it should be biodegradable. So one C is correct. Two is somewhat A, that is fine and stabilized at the end of the landfill, so greater than 10. So three ka B. Yeah, so that is option three. That is the correct answer. That is biodegradable. It will be when the landfill age is less than 5 years. Then intermediate will be somewhere intermediate 5 to 10, and finally stabilized when it is usually more than 10 years old. And this is also another the same thing. I hope you can see it. So you can see that based on the leachate type, the landfill age, these are the question like matching options which were shared in the question. If you look at the treatment efficiency, both biological and absorption based, since initially the nature is biodegradable, so the biological treatment will be have better efficiency, like best efficiency if I consider these three things. After that, in intermediate stage, it falls a bit and very poor in when the like the landfill is has become old and has stabilized, because most of the biological matter that was present there, it has also already been utilized. The substrates have already been utilized by the microbes, and the rest of the material or mass that is present there dissolved in the leachate. Most of it can't be used efficiently by the active microbes which usually participate in biological treatment. On the other hand, if we are talking about adsorption, initially it can be fair to poor, then it follows a opposite trend. Reason being, like, there can be various dissolved ions present in the leachate because it passed through different kind of materials. It can be various types of salts can be there, because once it starts leaching through the, some metals that can be present there, since it is acidic in nature, some of it can start dissolving the leachate. So that happens. And in the beginning, what happens that when there you have used, let's say in the leachate, you have used some kind of adsorbent, and it has basically, most of the time, adsorbent, it primarily functions on having a good surface area. After that, there are a few other parameters as well. But when I am using an adsorbent and putting it in a complex and heterogeneous mix of this leachate, which has got n number of things dissolved in it, or in case there can be also some suspended material as well. So then what happens is that the surface of that adsorbent on which the contaminant was supposed to get stuck and then remove. So what happens, instead of targeting the main component, the main contaminant, something else it interferes. The dissolved organic matter can be one of them. So it starts interfering with the adsorbent. It can form a layer around them, block the pores based on the size of the particles present there, or even molecules. So that can seriously hinder the efficiency of the adsorption process. So that is why, first, if we go for a biological treatment, if there is some organic material that is present there, particularly in particulate form, it can go through hydrolysis and other phases, and most of it, first it after hydrolysis, it comes down a major fraction of it to the dissolved state. Then after biological treatment, most of it gets removed. Then what is remaining, that will have a better efficiency if you want to remove it through adsorption, because those interfering materials and molecules and compounds, they won't be affecting it as much as it would have done if we have started with the adsorption process. Then we would have lost a huge amount of active area that is present on adsorbents, because that is how they function. The specific surface area of an adsorbent is a huge, uh, like important and vital parameter which defines its working efficiency. So I hope that was clear. Now we will move on to the next question. Okay. So which of the following is the primary reason that we flare the gases produced in the landfill? Primary reason for flaring landfill gas. Okay. So your options will be keep rodents away, so which one do you think is the correct answer? Very simple and very basic question. Why do we flare the landfill gas? The primary reason. Option 3, yes, it is the correct option. Basically to minimize the impact from GHG emissions, because we know that in landfill, majority of time it is in under anaerobic state. So what happens, we all know characteristically methane is the main product there, and if I look at methane, then it has got a much higher, around I think 25 times higher global warming potential as compared to carbon dioxide. So if CH4, one molecule of CH4 is getting emitted, it will have 25 times higher impact. So that is why if I flare the methane, I know that you will be, everyone of most all of you will be already knowing this. Still, I will just write the equation. When I am flaring it, basically I am combusting it. So what will happen? I need to put an arrow here. Fine. This is an arrow. So I will just rather use an equal to sign. Instead of equal to, this should be an arrow. Or I can use this. Fine. Let's say this is an arrow. So it basically gets converted to CO2 plus H2O. See, so you can see that one methane, it was 25 times more potent than CO2. So when we flared the same carbon having four hydrogen, it got converted to CO2, and that is why we kind of reduced the impact that would have been there if methane would have been released to the atmosphere instead of carbon dioxide. That is why we flared the gas. I hope this was clear for everyone. Now we will move on to the next question, which is question number 7. Now the question is, which of the following is not a property of landfill gas? Not a property of landfill gas. Again, a simple question. Yeah, these are your options. Yes, option 4 is the correct answer because landfill gas can be and is often very having a very foul odor. So option 4 is not the correct answer. Landfill gas is having a very foul odor. So that was the correct answer. So now the question number 8, it is a numerical based question and you have to calculate the landfill's capacity. SW is solid waste at the rate of 15 tons per day. So the landfill volume is, how much it is? 3 lakh meter cube. Let's see whether it is 3 lakh or not. Add a few more zeros. Yeah. So the landfill volume is 3 lakh cubic meters, and the density of waste that will be put into the landfill, it will be 365 kg per meter cube, with a solid waste acceptance rate in the landfill being 15 tons per day. So your question is, what is the capacity of a landfill with the data that has been shared with you? You can have about 5 minutes, 5-10 minutes to first think about this question, solve it, and then I will share the answer and solution in case it is needed. Yeah, these are the options. It is a very simple algebra-based question, very easy one-liner. You can, if you have the answer, you can share that in the chat box or unmute yourself. Otherwise, you can also give it a thought and we'll wait for a few more minutes and then share the solution. Okay, so option 3, that is 25 years, and option 2 is another 20 years. Okay. So we will see what we are getting. So my question is to calculate the capacity of the landfill liners. Fine. So first things first, I have to see that how much waste my landfill can hold. So my landfill's volume is going to be, sorry, it is going to be 3 lakh meter cube. and the density of the waste that we are going to dump in there, it is going to be 365 kg per meter cube. So very simple, very easy to calculate the total mass of waste that we are going to, that our landfill is going to accommodate. So let's see, total mass total mass of waste in landfill, it is going to be 3 lakh into 365. So I will use the calculator to see what it is. Otherwise, we will leave it like that, and the value will come out in kgs. And then I need to find the landfill capacity, and what we have been told is that the landfill is receiving 15 tons of waste per day. So now very easy, just we are going to divide them. So landfill capacity. So now this much kgs is what it can hold, and if it is receiving 15 tons per day, divide this value, total mass of waste in landfill, by 50. So we will have this divided by 15. Since it is given in tons, I have to multiply it by 1000, and the answer that I will get is in will be in days. So I will quickly calculate and see. Okay, and then if I have to like convert it into years, again I have to divide it by 365 itself, this entire value, if I have to convert it into years. So the correct answer is 20 years. That is option 2. I hope that was clear. In case if you have any doubt at any point, please feel free to unmute yourselves and share that with us, or you can also use the chat box. If it's all right, we will move to question number 9 then. In here, you have been asked that which of the following methods should not be opted in the absence of effluent treatment plant at a landfill site. Should not be opted in the absence of ETP, that is effluent treatment plant at a landfill site. And your options will be yeah. Among these options, which one do you think is the one that this question is pointing towards? Okay, so option 2 is the correct answer, as you all have rightly mentioned. And I hope that you also know the obvious reasoning behind it as well. Disposing such a toxic, having high BOD and COD loading and various other dissolved metals and other organics to any water body, it will be a serious issue there. Now moving to question number 10. So here I have to type a bit more. So you have been asked like what is the field capacity? Fine. Options are Yeah, so what is field capacity? And these are your options. Like is liquid. Yes, option 1 is the correct answer. Amount of liquid that a mass can hold prior to its downward percolation due to gravitational forces, because that mass has got various pores, and before the liquid actually starts seeping downwards, all the pores they need to be first occupied with the water. Once it is done, like 100% of the pores are filled with water, then we say that the field capacity has been reached, and whatever excess water we add thereafter, that net of that excess amount, it gets percolated below due to the gravitational forces. Now moving to the next question. Now, in the design of a landfill system, what is the purpose of a cap system? What is this? And the options will be, yeah. ओके, अगर आपने असाइनमेंट सबमिट नहीं किया है और आप असाइनमेंट देना चाहते हैं, एक्चुअली मेरे को आई एम नॉट डीलिंग विद दैट स्टफ। आप एक काम कर सकते हैं, आप सीधे एनपीटेल की जो टीम है आप उनसे उनको ये मेल कीजिए, एनपीटेल सपोर्ट को, आपका कोर्स आईडी, कोर्स नेम और आपका कोई रोल नंबर वगैरह, एप्लीकेशन आईडी कुछ है वैसा डाल के, तो वो आई थिंक बता पाएंगे। असाइनमेंट्स का कुछ वेटेज होता है, बट आप एग्जाम दे पाएंगे कि या नहीं, वो एनपीटेल का जो मेन जो लोग ये सब देखते हैं वही आपको बेटर आंसर देंगे इसका। ओके, वेलकम। सो इन दिस पर्टिकुलर क्वेश्चन, व्हाट इज द that what is the purpose of the landfill cap? So I can see that option 4 has been chosen, thought as one, then option 3 is another. Fine. So the basic reason why we keep a cap is that it is to prevent the infiltration of rainwater. So first, there is a liner, which is the main role of a liner is to prevent the seepage of the leachate into the further down into the soil and maybe reaching groundwater. We need to prevent that, so that is why we layer the liner. And it is also to keep the leachate inside the landfill system so that it can be pumped out from the lowest points of the landfill and then treated thereafter. But what cap does is that once you have filled in all your waste, it has already been compacted, but the role of cap is not to compact it. It is done in other ways. The role of the cap is mainly to keep the rainwater that is falling on the landfill, to prevent it from seeping into the landfill so that the leachate generation can be minimized. So that is one thing. And landfill gas out, it is not the correct answer, because another role that is plays is to keep the landfill gas in. So that can also be another role of the cap. Sorry. So in this particular question, the correct option will be to prevent the infiltration of rainwater. So now we will move to question number 12, and it talks about the role of geonet in landfill liner system. So we have already discussed it in one of the starting questions today. So I think you can quickly think of the answer. আচ্ছা সৌরদীপ, ওই ল্যাবে না বোধহয় ডিস্টিল ওয়াটার শেষ হয়ে গেছে, আমি একটু ভরে দিয়ে পারছি। SW is solid waste. Yeah, so these are your options. Which one do you think is the correct one? The role of unit in a landfill liner system. Option 4. Okay, let's see, a net is used. Okay, I think that due to the mention of this HDP, there you might be getting a bit confused. So yes, that when we have an HDP geomembrane, the role of that is to separate the fine granular materials with coarse granular materials, maybe that in the, yes, that in the landfill liner, but it allows water to flow through. Okay. So what is the correct? This is not the correct option. This fourth one, because GeoNet basically it doesn't allow water to flow through it. Like if I have a horizontal geo layer, GeoNet, then the water ideally it should not like percolate through it. The GeoNet, it basically what it does is that once the water comes or the leachate comes into the GeoNet, instead of going or passing through it vertically down, what happens is that it spreads horizontally. So that is why we say that it promotes transmissivity or lateral movement of water, so that we have got detectors at places. We can see that because GeoNet is also below the, like as a part of the liner, we will see or GeoNet acting as a kind of detector that can tell us that yes, there is some leakage into the liner. That is why in the GeoNet we are detecting it, because it spreads in horizontal directions. We have detectors at places, so then it tells us that yes, there is some leakage in the line. So that is why in this particular question, correct answer is option A, that is a synthetic HDPE material used for drainage of leachate, because it drains the leachate in horizontal direction. Then can be called as transmissivity or lateral movement as well. And in option D, why it was a bit confusing, because HDPE might be one of the reasons. Like some of you might have confused it with the geomembrane. And another point that could have helped us identify why option 4 is not the correct one, because it is written that it allows water to flow through. And this is absolutely not the property of GeoNet that is used in landfill liner systems. So I hope this was clear. Now the next, how many questions is that? 13, 14, 15. Yeah. So the next three questions, they have or they can have multiple correct answers. So just a disclaimer, and then you might need to think a bit more about them. So the first one is, that is a question number 13. What are the different leachate removal techniques from landfill? Yeah, so these are the options, and just a note that there can be more than one correct answer. Okay, so option 2 and option 4, this is 2 is correct because that is what occurs, flows down by gravity, and option 4 is pumping from low points. Yes, so both option 2 and option 4 are correct because we can't place n number of pumps in the landfill, then it will become uneconomical. So that is why we provide a landfill slope, one of the reasons, so that instead of getting the leachate getting collected at different places, the slope allows it to merge at a single point or few other points where the leachate finally gets accumulated. There is a pipe going through there, and that pipe, from it we can even pump it to other places where it can be treated. And option 3 is obviously not the correct one, and yeah, option 1 is also out of question. So 2 and 4 are the correct options. So then we will move on to the next question. So you have to think about the different methods for gas extraction from landfill of gas. Okay, so 2 and 4. Any other thoughts? Fine. So 2 and 4 is the correct answer. Passive wells are the wells in the landfill that are open to atmosphere. One end is open to atmosphere, and the one is inside the landfill. In active wells, what happens is that it is kind of an extraction system, which is the other end. Instead of being open to atmosphere, it is being linked to a or attached to a pump. So it sucks the gas out of the landfill. So in passive wells, the gases are released or coming out due to the pressure difference, while in active wells there is a pump there which sucks the gas out of the landfill. So this was the 14th question. Now we have the last one with us. It is about the okay. So the question asks that which of the following are the different anaerobic leachate treatment methods? Aerobic leachate treatment methods. So your options will be, this is also a very simple question. UASB reactor. Okay, so the full form of UASB is upflow anaerobic sludge blanket reactor. So that is the full form of UASB, upflow anaerobic sludge blanket reactor. So which of these are used for anaerobic landfill leachate treatment. Option 1 and option 3, yes, absolutely correct. Like it was quite obvious as well. So anaerobic digestion, you all must have already an idea. So a brief about the USP of the anaerobic sludge blanket reactor. What happens is that if you look at the name itself, like it says that there is an upflow. So the influent is coming from the bottom of it. So just a crude diagram I will show you. Very crude one. So let's say somewhere from the bottom there is an inlet. Okay, so let's say somewhere from the bottom there is an inlet. That is why it is said upflow, and then it is under anaerobic conditions. So we have few domes at top of it so that the air doesn't comes in. If you maintain it in the anaerobic conditions, it can be in the bottom. Instead of this, you can also have a normal pipe here. And then sludge blanket reactor. Why we are telling it as a sludge blanket? So what happens is that when the waste water it starts coming from the bottom and move upwards, it starts forming a sludge. So that sludge, it is forming a layer somewhere here in between. It forms a layer. And why is it floating? Because during the anaerobic digestion process there are gases released, and those gases they keep on getting stuck or absorbed on the sludge surface, making it kind of a buoyant kind of effect, so it doesn't falls down. That is why it somewhere floats in between, and it helps in further degradation of the wastewater that is coming in, because when it forms a blanket in between, like if you have your wastewater and you have some particles or other organic materials, particulate organic materials, solid materials in there, so it can't just go through it and reach at the top, because at the top there is somewhere an outlet. Let's say the outlet is somewhere here, so it won't happen that it will just bypass the entire thing and move out along with the effluent. So the solids, it gets trapped into this sludge blanket, and after the treatment occurs, some of this sludge, the solids present in the sludge blanket, it also forms at the bottom, falls at the bottom from where it is removed after regular intervals. And as you can see that that is why the solids, it doesn't usually like pass through this blanket and comes out at the effluent. That is one of the roles of the sludge blanket. And then we have a dome at the top. What happens is that the gases which are formed, they are collected in these domes, and sometimes in case there are few solids which are bypassing the sludge blanket, in case, because nothing has 100% efficiency, then we have also got some separators here which can be somewhat like inverted triangle shaped. So these uh, solids which are bypassing the sludge blanket and moving upwards, they are also often having some adsorbed bubbles, air bubbles with them, or other gas bubbles. That is why it is reaching at the top. Because if you look at the specific gravity of that sludge particle or the solid that is present there, it is more than that of water. So ideally, it should sink down. But due to the presence of that adsorbed air bubbles or gas bubbles, it gets an extra buoyant force and starts moving upward. But at the top there are some separators. When it's struck with the separator or hits it, so the bubbles, it separates itself from the solid or sludge particle, and once it gets separated, the solid, it again falls down and it joins the sludge blanket. Or after some time it can also further fall down the sludge blanket and collect at the bottom of the USB reactor. So that is a very crude, very basic explanation of how things work at USB. And in fact, it is a, if you want to really take a deeper look into it, there are other courses offered by IIT Kharagpur through NEPTEL. You can always go through them for have a better understanding. And one of those courses is, I think, taken by Professor Makarand Madhav Gangrekar, where a very good explanation of this USB has been provided. Fine. So that was it. these are the 15 questions that we had with us today. I will quickly go through all the questions again for those who have joined us a few minutes late. So in today's live session, the first question was, we have been asked to find the model which is used to determine the amount of leachate that is generated in landfill. And the correct option was hydrologic evaluation of landfill performance. That is one model which is used to determine the quantity of leachate that can be generated, and this is often abbreviated as HELP model. So that was the first question. Then in second is, which is the most important property of GeoNet that helps in the collection of leachate during waste degradation in landfills? So this particular similar question we also got at the end of also. That is why I was saying that these are similar questions. So the one of the major properties of the GeoNet is that it allows transmissivity in horizontal direction. That can help us, or that is what helps us often to detect any kind of leakage that is present in the landfill liner system. Then in the next was, what is the typical slope of a landfill liner which is preferred? So the correct option was 2 to 8%, because this 20 and 10 to 15, these are too much steeper slope, and if such slopes are used, there will be like added cost for digging, excavation, and in fact pumping costs of the leachate can also increase. So that is why 2 to 8% is the usual cost. Yeah. So the next question is, the BUD is stabilized in which phase of the landfill? Whether it is in methane forming phase, acid, preliminary aerobic, or final aerobic. So in order to answer this question, we took the aid of a diagram here. So in this diagram, you can see that the BOD, it is reaching its peak somewhere in the acid forming phase, because most of the COD that is present in the leachate, it is reaching its maximum in this acid forming phase, because some of the solids which are present there also gets hydrolyzed, then acidogenesis occurs, then acetogenesis occurs. In all those cases, as the VA phase of volatile fatty acids, they starts accumulating in the leachate. So that is also where the BOD also increases. But once this acetogenesis occurs, after that there is a methanogenesis, that is a methane forming phase, and in that the organic material or the carbon in the organics present in the leachate, they starts getting transformed to methane and carbon dioxide. So that is why the biological or the biochemical oxygen demand, not biological, the biochemical oxygen demand, it starts falling there, and somewhere in the methane forming stage, it becomes stable. So that was it. Then in next question, it was a match of the following type, which wants us to select the landfill age and relate it with the type of the landfill or the age or the stage of the landfill. So if the landfill is biodegradable phase, then it means the age is less than 5 years. After biodegradable phase, when most of it gets already degraded, it reaches an intermediate phase, which obviously looks like 5 to 10 years, and then stabilized phase, which is more than 10 years. So this was the correct matchup. Then the question was the primary reason for flaring the landfill gases. In here, the primary reason was to minimize the impact of greenhouse gas emissions. Why? Because methane is a primary gas that is produced from landfill, and it is almost 25 times more potent green global warming potential, or more potent GHG than carbon dioxide. That is why we flare it, or we combust it. Then it gets converted to CO2, and which is typically much less potent in terms of global warming potential than methane. After that, we have the question which is saying that out of these four, which is not a property of the landfill gas? The correct answer is odorless, because instead of being odorless, the landfill gas is having a very foul odor. The next question was a numerical based one, very simple. You have been asked to find out the landfill's capacity, and what you have been provided is with that how much solid waste the landfill receives each day, and then what is the density of the waste that is there in the landfill, and what is the total volume of waste that can be accommodated there. So multiply the volume by the density, and you will get the total mass of waste that the landfill can hold. Now, in order to determine the amount of years in terms of landfill capacity for which it can keep on receiving waste, you have to simply divide it with the waste acceptance rate, 15 tons per day, and then you will get the answer, that is 20 years. After that, we had a question which asked that which should not be operated in the absence of ETP at a landfill site. So all of you correctly mentioned that we should not dispose it off to nearby lakes for dilution because the COD of landfill, the BOD of landfill, it is absurdly high as compared to any normal sewage. So along with it, it also contains various dissolved contaminants, which are not typical for sewage, but much more characteristic towards landfill for landfill leachate. That can be various dissolved metallic ions, various dissolved minerals can be there because the leachate it is acidic in nature. Because when if you try to take a look at its phases, you will see that there is acidogenesis, acetogenesis. So these are all containing volatile fatty acids. So when there is an acidic environment, so what happens is that metals they tend to leach from the solid phase to the liquid phase. Like this is the usual or general typical behavior of metals. So that is why we see the ionic conductivity or the total conductivity of the leachate to be very high, much more higher than the normal sewage. So that is why it should not or never be disposed of to any water body with the intention of dilution. It can also only be done in that way once it has passed through suitable and appropriate treatment effluent treatment units. So the next question was related to the definition of field capacity. So this also every one of you have answered correctly. Like field capacity is basically the amount of liquid that a given mass of waste, or in fact it can be soil also, that it can hold or absorb prior to the downward percolation of the water due to the gravitational forces. Basically what happens, like any waste or soil, it has got pores. So first the water it starts occupying all the pores, and once it is done, then the excess water that you add to it, it tends to flow downwards due to gravitational forces. So that total amount of water that a mass can hold, it is called field capacity. Now the next question was the role of the cap in the landfill line. So its major role is to keep the landfill gas in and to prevent the infiltration of rainwater. So since the first option is saying exact opposite, so that is why it was not the correct one. Instead, option 3 was correct because it is talking about the prevention of the rainwater coming into the landfill by infiltrating the cap system. Then again we had geonet, the same thing, the role of geonet. So in here the correct option was option A, where this material is used for the drainage of leachate. The leachate, it comes in contact, when it comes in contact with the geonet, it flows in the lateral directions from where it can also be removed and in fact detected as well. Then I have like we had the question about the different leachate removal techniques that we often see. Among them, the correct answer was draining by gravity. The leachate container points. Yeah, so this was a multiple choice question. So in here, draining by gravity and pumping from low points, these are the correct answers. And then the next question is also similar in nature, where the different methods for gas extraction system were asked, and it was passive wells, where one end of the well is inside the landfill, other one is open to atmosphere, and active wells, where one well is inside the landfill and the other end is connected to a pump that sucks the air out, creates a negative pressure gradient, and sucks the pressure out of the system of the landfill. After that, we have got anaerobic leachate treatment methods. You have been asked like among this which of them is anaerobic, and if you look at the full form of USP, upflow anaerobic sludge blanket, that anaerobic, the term itself, it is present in the name of that reactor. And then we have anaerobic digestion. So obviously option 1 and option 2 became our correct answer. So these were the questions that we had in store for us today. And in case if you have any doubts or you have any points that you would like to share or discuss with us, you're always free to use this platform, or you can also share that in the chat box as well. If not, like then we can meet in the next live session, which will be in the coming Monday, the week 10 live session. We'll meet then. Just a note, like if in case if you have nothing else to discuss, it is not mandatory to stay here for 2 hours. You're free to leave the session anytime you want. And if you have any doubt, any queries, you're always welcome to discuss that.
उधर क्या है अभी चलिए
হ্যাঁ এখন এই অনলাইন আছি একটা অবধি 2 ঘন্টা। হুম, হুম, হুম।